Hello everyone. For potential energy problems for stable and unstable equilibrium points, you have seen that your potential energy function was given in terms of the x coordinate. Then we find dv over dx, and in third step we put dv over dx is equal to 0, and from here we find the points. Then we find d2v over dx2 and d2v over dx2 at points. If it is positive, then the points are stable equilibrium points. Points are stable equilibrium point. But if d2v over dx2 is negative, then the points are unstable equilibrium. But sometime what happens that d2v over dx2 at points is equal to 0. So now how we will solve in the such type of problems where d2v over dx2 is 0 at the points. This is the third type problem. Here we will find the value of the higher derivatives of dv over dx for even terms. Means we will find d and v over dx to the power n, where n is even number. So if d to the power n v over dx to the power n is positive, for higher values of n, then it will be a stable equilibrium point. And if d to the power nv over dx to the power n is negative, then it will be unstable equilibrium point. Now we will understand this by some examples. The first example is, let us say Vx is equal to alpha x to the power 4. Here alpha is greater than 0. Now we have to find the stable and unstable equilibrium point. For it we will find first dv over dx. So it comes out to be, because alpha is here constant, so it becomes 4 alpha x cube. Now we will put it equal to 0, dv over dx is equal to 0. So 4 alpha x cube is equal to 0. That means x is equal to 0, or we can say it as x equal to x0. Now we will find d2v over dx2. It comes out to be 12 alpha x square. So here when we put x equal to 0, then you see that d2v over dx2 is equal to 0. So now we will find the higher value of the dv over dx, where n is even term, right? So the next higher even term will be 4, because n can be 2, 4, 6 and so on. So we will find here, first I will find d3v over dx cube. It will be equal to 24 alpha x, then d4v over dx to the power 4, it is equal to 24 alpha, because alpha is greater than 0, so it is a positive term. That means x equal to 0 is here a stable equilibrium point. And is second type, the problem is here we can say it is type 4. Here you will see that in this problem v is equal to alpha x cube. Alpha is greater than 0, and we have to find the equilibrium point, and then we have to check it is stable or unstable point. Here we will find dv over dx. So dv over dx is here 3 alpha x square. Then we will put dv over dx is equal to 0. That means 3 alpha x square is equal to 0. That means x equal to 0. Now we will find d2v over dx2. This will be equal to 6 alpha x. Now when we put x equal to 0, then you see that d2v over dx2 is equal to 0. Now we will find d3v over dx3. It will be equal to 6 alpha. Then we find d4v over dx to the power 4, because alpha is here a constant, so it becomes 0. So in such type of problems where the higher terms of the even dv over dx term becomes 0, then in such case we will say that the point is neither stable nor unstable. So x equal to 0 is a point which is neither stable nor unstable. Right? So here hope you have understand it, that for only even term of the dv over dx, if these are equal to 0, then that point will be neither stable nor unstable. Thank you.